Now, what I'm illustrating there is that you've seen how we can go from a collimated telescope where everything is lined up like this to it being uncollimated. All right? That's the simple case. The more complex case is when that secondary mirror up here is also out of alignment. I won't go into that in detail right now because I think the more important thing is to cover the primary mirror. All right? If we can get the primary mirror right, that's the one which is generally the simpler of the two to get right because it's got adjustment screws there which are easily managed. There are adjustment screws in the secondary as well to adjust the tilt on that. Generally speaking, they're much smaller, and in this case you actually need a screwdriver in there to do the adjustments, and that can spell trouble because generally speaking you've got the telescope tilted up for height so you can look through it. You've got a dangerous screwdriver up here which could easily fall through and hit the primary mirror. Okay? So in this particular telescope here, you need to use some sort of tool to adjust that secondary. Larger telescopes have a larger area for the secondary mirror. They may well have small knobs you can get your fingers on so you don't drop anything in there. But the thing to remember is when you are adjusting these, never ever let go of that screwdriver. And in fact, if you can, tie a little lead on the screwdriver around your wrist. I've done that. Sorry, I haven't tied something to my wrist, but I've dropped a screwdriver before. Luckily, it was in a truss tube telescope similar to this one, which had open truss all the way down to here, and the screwdriver dropped and rolled out through the truss. But if it was a full tube or even one like this, the screwdriver may have ended up with the sharp bit down onto the mirror. That's the last thing you want. Okay? So that's a little trap to avoid. So at the moment, I'm not going to put the secondary mirror out of alignment so you can see that effect. That generally is not going to be the problem. 90% of the time the primary will be the problem. So what I'm going to do now is very quickly get you guys up again in a sec so you can see what this thing here is used for. And what you'll find is that when you look through that little hole in the top, you'll see these little crosshairs down the bottom here. Now, depending on, to be honest, how old you are and how good your eyes are, you'll either see nicely focused crosshairs or you'll see blurry ones. I see blurry ones, so there you go. But the blurry lines are good enough to do what you need to do. So to use this thing, start off with, put it into the top of the eyepiece again. And what you will be looking for is now that the reflection of the primary mirror is centered under those crosshairs. This might be a bit easier for you to see this time, Sue. You'll see those crosshairs there, and you will also see that the reflection of that small primary mirror is no longer under those screws. It's off to the side. And it's off to the side back towards the telescope. Okay? Ultimately what we need to do is to get that centered again. Alright, just look through here. Okay? Yeah. You can see the crosshairs now, yep, defining basically the central axis of the telescope for you. Yep. But that small secondary is off to the side. It's actually down here at sort of a 4 o'clock position, isn't it? Yeah. Yeah, okay. Now what you're looking at there is the big mirror you can see is a primary. What you want to do is to get that in the center. In this case, what I showed you was a primary mirror more or less in the center of those crosshairs. Okay? And that's because that secondary is pretty well centered at the moment. If I'd actually adjusted that secondary, we'd be here for a lot longer than we've got time for today to get it back into collimation, and that primary mirror would have looked offset from the crosshairs. Okay? Now the next thing to do is when you look at that, you can see that you've still got your primary mirror more or less with its center defined by those crosshairs. But you saw that that little central mirror was off. Okay? The fact that your primary is centered, but the little secondary mirror is off, means it's the primary mirror that needs adjusting. So the challenge now is to get that get the primary mirror adjusted to bring back the secondary reflection into the centre. You with me? It's a bit like trying to explain brothers and sisters and uncles and aunts and nephews to me. I always get lost. Okay, so if you do get lost, just stick your hand up, we can go through it again. But you're basically going to be adjusting that primary to shift that little secondary reflection back into the centre. Okay? Now, I think the easiest way of doing this is if we get... Steve, you want to give me a hand? In fact, you're going to look through here, okay? Yep. And I'm going to adjust that down there. And then once you see what's going on up here, I'll get you to adjust down here for everybody else as they come through while I talk.
Okay.
Okay? And before we do, I'll just remind you, once we've done this and you've got some idea of what's going on the back there, then I'll just go through with the laser collimator very quickly too. All right, now let's see if I can stretch around here. I'm adjusting clockwise. You see it?
The other way.
Yeah, the other way?
Yep, keep going.
I'm clockwise now.
That's it.
Okay, if I go too far clockwise, what happens?
Stop. Right.
Back?
That's it.
Okay.
Just the other one now.
Now at that point, you're really happy that it's getting towards the centre but not quite there?
No, I've got the two small dots.
Can I have a quick look?
Yep.
Yep. What Steve's doing, haven't shown him this before. So what he's doing, he's seeing the crosshairs and he's seeing the secondary, that small secondary plus that little circle right at the bottom. And what he's trying to do is he's trying to get that all lined up at the moment. And what he just suddenly found is that he can't get it lined up with the one adjustment screw that I'm using. So now I've got to go to another adjustment screw. Now, a handy thing to do is to label these adjustment screws on your telescope, 1, 2, 3. You can put a label on there, or on the night, with the person who's helping you, you agree, number 1, number 2, number 3. Because what will happen is, this process, you only get so far with one adjustment screw, then you need another one, then you need another one. Then guess what? You repeat the process again, so you're zeroing in on that, and you need to be able to say to the person who's helping you, no, number 3 now. Oh no, it's number 1 now, okay? All right, Steve, so we were using number 2. We'll pick number 1, one way or the other. I'm going anti-clockwise.
That's it. No, back up, back up, back up.
Okay, clockwise. Right.
You'll be about half an minute.
Okay, so we're fairly close? All right, so again what we're demonstrating is you need to understand what numbers here and which direction you're going, because what will happen is, over here, you might be looking through the eyepiece and your black ring or black dot is doing this, up and down, but your centre is here, so now you need to pick another adjustment screw. Okay? Doesn't matter which one you pick generally for the first test, but after that you want to know, no, I need number 2, because by then you'll see which screw is going in which direction. Okay? All right, we have that pretty well collimated. Now Steve, I want you to uncollimate it, please. Now, considering the time and the number of people here, we won't get to collimate this for every person. What we need to do though is to give you the opportunity of seeing how it can come back into collimation by adjusting those screws. Okay? Okay, Steve, pick number 3. And what was your name?
Ray.
Ray, okay, Ray. Now Ray, you should be able to see that that secondary mirror is now off the crosshairs again?
Yes, it
okay.
is, yeah.
Okay, ask him to go clockwise or anti-clockwise.
I have no idea.
It doesn't matter. Pick one.
It's coming in closer. Whatever you're doing is good.
Which way are you going there, Steve?
Clockwise.
Okay.
Clockwise. Keep going clockwise.
A little bit more. A little bit more. A little bit more.
Clockwise.
Yep, a little bit more.
Clockwise.
And a little bit more. And you're on it right now. Oop, stop.
Oh, want to go back a bit?
No, it's pretty good for
Okay.
my eyes.
All right. That's basically all we've got to do. Now, the silver ring, by the way, I forgot to explain, is the reflection of that 45-degree angled oblique ring up here. Keep your eye through there. I'll put my hand over here.
Gone, yeah.
Silver ring disappears.
Yep.
That's why you need light to make that silver ring for you.
Okay, so that's that little centre silver
Now,
ring.
you've got the little silver centre ring, and then you can see above that at 12 o'clock that little black ring.
Yep. Start going clockwise with
Now,
number 3.
clockwise number 3.
Yep. Now you're moving further away.
Okay. Moving further away. Back the other way, Steve.
I need to go down there.
So that means change direction to Steve. Can't quite get there with this particular adjustment screw. So now you need to choose a second adjustment screw and turn that one way or the other.
Okay.
I'm thinking number 2 is the real small black one.
Are you going further away?
Alright, go that the other way.
Other way. That's pretty good.
Okay.
Do you want to have a look at that? See if that's right.
Let's have a look. Yep. So this is the sort of communication you're going to need. Now, this is a 10-inch telescope. Generally speaking, it's going to be too long for most people to do these adjustments by themselves. 6-inch or an 8-inch you can usually do by yourself. Much easier. And laser collimator. The idea of the laser is to provide you with an idea of where the axis of the secondary mirror is. What do I mean by that? What I mean by that is that when you shine light into the mirror here, it goes down through the center of the telescope to the center of the primary mirror. Okay, that's what you're trying to do. Now, it's going to be a bit harder here to illustrate, but if we all want to come up here for a minute. And I think my battery might be going a bit flat on here, so. But can you see the red dot on that ring? Okay. What we want to do is to get that red dot lined up in the center of the black ring. Can you see that there? Yep.
Does the voids have to look through the eyepiece on this?
You're not using the eyepiece at this point. You are simply trying to, what you're testing here is the tilt of the secondary mirror. And you want to get that secondary mirror to take that laser light and shoot it at the center of that ring. Okay? Now, the other thing that you can do with this, you can imagine if your focuser wasn't sitting square on your tube, if it was offset like this, as you rotate the laser light, if that's offset there, and you turn your laser light here, your little laser on the end of that mirror there will actually do a circle. And that's an indication that you've got a problem up here. So that's the other handy thing. Now, for those of you who at some point decide that I'm going to build one of these, and believe me, a little bit of reading and some skills, and you can build one of these. As soon as you build one of these, you have to be able to place the secondary in the central position for the first time. A laser like this one is very useful for lining up the telescope from the very beginning. Okay? Now, the workshop today doesn't tell you everything about collimation. What I've tried to illustrate that there's some basic fundamental things such as getting things, the central secondary lined up, the primary lined up, making sure your focuser is lined up with the use of a laser collimator. The finer details come down to printing off some material out of a book or off the internet, reading it and doing it for yourself.